In 2024, construction crews broke ground on the second of what will eventually be up to 12 fabrication facilities on a campus outside Phoenix, part of a commitment that has grown past $100 billion and that American politicians described as the most consequential industrial investment in a generation. The pressure to build those fabs did not come from China's military posture toward the island. It came from Washington's own export controls, and the law that quietly followed those fabs to Arizona ensures that the chips America most needs are the ones Taiwanese law permanently reserves for Taiwan. Here is what that chain looks like when you trace it link by link. The Arizona campus is real. The investment is real. But sitting above the entire project is a legal ceiling that the public debate has not named directly, and understanding how that ceiling got there requires starting in Washington in late 2022. The chain runs 5 links. Each one is graded for how solid the evidence is. The link the whole inference about permanent strategic lag hangs on is a Taiwanese statute, not a fab construction timeline, and that distinction changes what the $100 billion actually buys. In October 2022, the United States Commerce Department's Bureau of Industry and Security issued sweeping export control rules that restricted the transfer of advanced semiconductor manufacturing equipment and certain chips to China. Subsequent updates tightened those controls further. This is confirmed on the public record. The stated rationale was supply chain security. The United States government concluded that allowing China to acquire the tools to produce leading-edge semiconductors at scale posed an unacceptable strategic risk. That judgment and the controls that encoded it had an unintended audience. Taiwan's government and its semiconductor industry watched Washington declare that control over leading-edge fabrication was a strategic asset worth restricting by force of law. The signal was unmistakable. Whoever held the leading edge held leverage. That is confirmed link 1. What those export controls triggered in Taiwan is confirmed link 2, and it is the one the whole downstream inference rests on. Under pressure from the American CHIPS Act and associated diplomatic commitments, Taiwan Semiconductor agreed to build multiple facilities in Arizona. The investment grew, the facility count grew, and as those commitments solidified, Taiwan's government formalized what had previously existed as an informal industrial policy preference. Advanced process nodes, confirmed at 2 nanometers and below, may not be manufactured outside Taiwan until Taiwan's own domestic production has already moved beyond that node. The statute encodes a permanent generational gap by design. Arizona can build, Arizona can produce, but the nodes Arizona can legally produce are, by Taiwanese law, always one generation behind whatever Taiwan's leading domestic facilities are running. The anchor here is the Arizona campus itself, the physical site where the legal ceiling first became concrete, not just a policy preference, but an enforceable boundary written into statute. This is where the expectation turns over. The policy designed to reduce American dependence on Taiwanese fabrication produced the statute that made that dependence permanent at the node level that matters most. The restriction did not sever the chain. It wrote the chain into law. Most reporting on the Arizona campus has focused on the construction timeline, the workforce, the subsidies, and the geopolitical symbolism of American fabs rising in the desert. What that framing misses is that the legal ceiling is the story. The fabs are visible. The statute is the actual mechanism. If that law is modified, the entire downstream inference about permanent generational lag collapses. Every conclusion that follows from here depends on that legal language holding. Confirmed link 3 follows directly from the statute. If Arizona fabs are legally capped at 1 generation behind Taiwan's leading edge, then American chip designers that require the most advanced nodes cannot fulfill those requirements from domestic production, regardless of how many facilities open in Arizona and regardless of how large the investment grows. The companies most exposed are the ones building artificial intelligence accelerators and high-performance compute hardware. Those designs are the most node-sensitive in the industry. Transistor density, power efficiency, and die size all move substantially between process generations. Sourcing from an older node is not a minor engineering adjustment. It changes the product. This effect on American fabless companies is widely reported by semiconductor analysts, and it follows structurally from the confirmed statute, so the grade on this link is confirmed. The performance and density differences between adjacent process nodes are well documented in semiconductor engineering literature. Moving from a less advanced node to a more advanced one typically yields meaningful gains in transistor density, which translates into lower power consumption, smaller die area, or more compute per package for the same design. The compounding nature of that gap across multiple product generations is where reported link 4 begins. As artificial intelligence compute demand accelerates, the distance between what Arizona can legally produce and what Taiwan's leading facilities are running is not symbolic. It is measurable in product cycles. A chip designed for an artificial intelligence training workload that is fabricated at the Arizona node ceiling will consume more power, occupy more die area, or deliver lower throughput than the same design fabricated at Taiwan's leading edge. That gap does not stay flat. It compounds with each new generation because the Arizona ceiling moves in lockstep with Taiwan's domestic production rather than catching up to it. Here is the hardest mechanism to hold in mind. Think of it the way a highway on-ramp works. If you merge one exit behind the lead car, you are simply behind, and that is one generation of lag. But every time the lead car accelerates, you are already starting from a position where you are behind and still accelerating. The distance does not stay constant. It grows with every acceleration unless something in the system changes the merge point. The Arizona fabs are permanently merging one exit back by statute, and artificial intelligence compute demand is the accelerator pressing the lead car forward. The compounding effect is reported as directionally solid by industry analysts, though the precise magnitude depends heavily on which workloads and which design families are in question. The gap for a mobile application processor is not the same as for an artificial intelligence training accelerator. That is a real data limit worth naming. Inferred Link 5 closes the chain and carries the sharpest irony. The United States policy argument for the CHIPS Act was that domestic production would reduce strategic dependence on Taiwan for the most critical semiconductors. The legal structure Taiwan enacted in direct response to that investment ensures the strategic dependence for leading-edge nodes is not reduced but codified. The most important chips are not merely manufactured in Taiwan by market preference. They are reserved there by law. Taiwan has not publicly framed the statute as a direct counter to the CHIPS Act, but the timing and stated rationale align closely enough that the causal link is a reasonable inference, not a confirmed fact. The grade is inferred. The sequence is hard to explain otherwise. The call that matters most here, and the one analysts are underweighting, is about which American companies feel that ceiling first. It is not the fabs. The fabs are suppliers. The companies that feel the ceiling first are the American fabless chip designers, the ones headquartered in the United States that design artificial intelligence inference hardware and high-performance compute chips, and then contract fabrication to the most advanced available node. Those companies cannot source leading-edge nodes from Arizona, regardless of how many Arizona fabs open, because Taiwanese law prohibits it. They must go to Taiwan. The Arizona investment does not change their supply chain in the dimension that matters for their most advanced designs. That is the link that receives the least public attention and carries the most strategic consequence. The second call worth making out loud is about the assumption that one generation behind is a stable, predictable interval. Node generations are not evenly spaced in time or capability. The engineering distance between 3 nanometers and 2 nanometers is not the same as the engineering distance between 28 nanometers and 20 nanometers. Earlier transitions involve straightforward dimensional scaling. Later transitions involve new transistor architectures, new materials, and entirely new manufacturing approaches. Treating the lag as a fixed interval the way the headline number implies understates how much the gap could widen at advanced nodes, because the leading edge is where the engineering jumps are largest and least predictable. The reported compounding is directionally right. The magnitude is genuinely uncertain. Now for the soft links, because the chain has them. The entire inference about permanent strategic lag rests on the assumption that the Taiwanese statute as currently written will remain unchanged. That is not nailed down. Taiwan has a demonstrated history of adjusting industrial policy under diplomatic pressure, and the law's specific enforcement mechanism has not been stress-tested by a case where an American customer explicitly demanded a leading-edge node from an Arizona facility. What happens when that collision occurs is not yet on the record. There is also a genuine data gap on the demand side. It is reported, but not precisely quantified, how many American chip designs actually require nodes below 2 nanometers within the next 5 years. That matters for whether the ceiling is immediately binding or a future constraint that has not yet bitten. And the question of whether Taiwan Semiconductors' Arizona fabs could be granted an exemption or whether a future Taiwanese government would renegotiate the threshold node is open. Those are the places where the chain could break. The synthesis is this. The chain is solid from cause through effect at every confirmed link, but the question of whether the legal ceiling is durable rather than a current administration policy preference is where the whole inference about permanent strategic lag either holds or has to be revised entirely. What the Arizona campus represents at this point in the chain is worth stating plainly. 12 facilities, $100 billion, the most politically visible manufacturing commitment in American industrial history. And sitting at the top of it is a legal ceiling that ensures the chips America can make at home are not the chips America needs most. The campus is real. The generational gap is written into Taiwanese statute. And that statute was enacted in direct response to the pressure to build. The Arizona campus, which entered this chain as a symbol of American industrial ambition, exits it as the physical object that embodies the chain's inversion. It is the site where the ceiling first became concrete, where the legal language became a construction blueprint, and where the distance between what is possible and what is permissible is most visible. The chain inverted. The move to secure supply created the law that constrains it. The fabs are in Arizona, the nodes are in Taiwan, and that arrangement is not an accident of geography. It is the deliberate conclusion of a legal process that American policy set in motion. Watch for whether the Taiwanese government adjusts the threshold node upward as its own domestic leading edge advances. If the ceiling moves with the frontier rather than falling away from it, the lag is structural, not temporary. If the threshold stays fixed at 2 nanometers while Taiwan pushes to 1.5 and below, the next process generation will tell us whether this was a policy posture or permanent architecture. That is the number to track, and it will not appear on a construction timeline. If you track the chain rather than the headline, subscribe and turn on notifications. This is what we cover.